Hi, and welcome to question 2 of the 2024 Junior Cert Higher Level Maths. So this question is around statistics, and I don't have the marks as the marking schemes aren't out yet, but we'll read through it and we'll see how we get on. The table below shows the distances in centimeters jumped by a group of students during a school long jump competition. And they kindly give us a picture of somebody doing a long jump. And it says in the table, the distance jumped 0 to 80 centimeters, nobody. Okay. 80 to 60, 2 students. 160 to 240 was 7 students. 240 to 320 is 12 students. And 320 to 400 is 3 students. Now it notes in the bottom that, for example, 80 to 160 means from 80 centimeters up, but not including, but less than 160 centimeters. And then the 160 centimeters is counted in here, all the way up to basically 239, and then 240 up to whatever. Now it says work out the number of students who jumped less than 240. So if you think about it here, well, nobody jumped between 0 to 80. Okay, so you could count that if you wanted, it won't matter. 2 students got between 80 and 160. Okay, so they're included. Then 7 students got within 160 and 240, so they jumped less than 240. Now we don't include any of these because they jumped more than 240. So 0 and 2 and 7 is 9, 9 students. And that should be it. I'd always suggest putting a box around the answer. And I'm going to check. Yep, that's from just the notes, so that's perfect. Then part B says, draw a histogram to show the information in the table. Now I've put the table in here up top. It says use the axes and scales below. So they've thankfully given us the graph itself. So on the y-axis, we have the number of students. And on the x-axis, we have the distance jumped. Okay, so between 0 and 80 there's nobody, so we don't need to put anything in there. Now in a histogram, the bars always join. Okay, so between 80 and 60, there was 2 students. Now I'm not going to use a ruler or anything like that because I'm on a tablet, but you should be as neat as possible. 160 to 40 up as far as 7. Now they don't count 7 on that, but it's between 6 and 8. So you're supposed to make the leap that that's 7. 240 to 320. I'm just going to go to the answer. That's up as far as 12. And then 320 to 400 is down as low as 3. That's it. So handy money, as long as you don't get scared off by the word histogram. So in a sense, you think it's just kind of like a bar chart. There can be situations where histograms can be awkward, and they're kind of like an advanced bar chart. So question 2 part C reads, work out the maximum number of students who could have jumped more than 200 centimeters. So, well, these students here between 0 and 80, they didn't jump more than 200, so they're gone. The ones here who jump between 80 and 160, they didn't jump more than 200. Now, the students here from 160 to 240, like they all could have jumped 160, or they all could have jumped 240 or 239, whatever, or probably a mix of numbers. And that is the problem with a grouped frequency distribution. Ungrouped frequency distribution might be something like 2, 5, 3, 4, like whatever. There's 5 things that happen twice, whatever way the scale is. There's no range, okay, in the data, okay. I'm saying that wrong, but all 7 of these students could have jumped to 220, which is above 200, so they have to be counted, okay. Now everybody else, the 12 and the 3, well, they're obviously jumping more than 200, okay, and that is 22 students, and that's it. Okay, now the next one says use mid-interval values to estimate the mean distance jumped by the group of students. Give your answer correct to the nearest centimeter. So the mean of distribution, okay, so the mean is equal to the sum of the frequency times the data, all divided by the sum of the frequencies. Now the frequencies are the number of students. So I straight away I know that is 0 and 2, and 7 is 9, and 12 is 19, and 3 is 24. So that bottom number there is 24. Now the top part I get by multiplying the sum of, so add them all together, and that's going to be the sum of the first frequency there is going to be the frequency that's not going to matter is 0 times the data. But what's the data? Is it 0? Is it 80? I don't know. Okay, so we have to kind of arrive at a compromise, which is the halfway point between 0 and 80, which in essence is the mean of that. But it's like add 0 and 80, you get 80, divided by the number of them, which is 2, you get 40. And that's the mid interval value. Okay, so we're going to add that to, now you can put them in brackets, but the calculator won't care. Or if you're using the calculator, you keep going that vein. The next one is the frequency is 2 times the mid interval value there is 120 halfway. Okay, plus, and you keep going in that vein, and you end up with this calculation. Now you can either program it in the calculator and you get this intermediate number, or if you go straight to a decimal, you get a mean of 253.33. Now the question does say give your answer correct to the nearest centimeter. So 0.3 is less than 5, so the number before it stays the same. So 253 centimeters. Now, I would always suggest that if you are doing this out, even if you are using the calculator, which is probably what a majority of students, I'd love to know, but a lot of students are doing, is the calculator. If you are, still show this calculation, because it's very easy to program the calculator incorrectly. And if you do, so wrong answer with no work shown is going to be given 0. Whereas if you have the formula and you accidentally get the wrong answer through the calculator, you'll still score very, very highly. Okay, because the the methodology is right. Now I just realized I have this 10D shouldn't be in there. I'm marking this before or making this before the marking schemes are out. Okay. Okay, so the next part here says estimate the median distance jumped as accurately as you can. Now, the median, okay, is actually a really simple concept, and it's the middle number, but when organized by increasing size. So it's the halfway point. Now you kind of can judge it here. You can go, well, look, if would it be in the first one? No, it can't, because that's not the middle. That's not the middle. Maybe it's in here, or maybe it's in here and it's not in here. So which one is it? Okay, so if I count up 0 to 7 is 9. Okay, now 12 and 3 is 15. So there's 15 people over here. So you have to be the halfway point, which would be 12. Okay, so the 9th or the 12th student should lie somewhere in there. So my answer would be 240 as far as 320. Okay, there lies between the 12th and 13th values. So we know there's 24 students. Halfway point there is 12. So where is the 12th student? So again, it's not here, it's not here, it's not here, but the 12th student is in here, okay, somewhere. Okay, and that's the median. So the pretty easy concept, and in statistics, they may assess, like we misuse sometimes the word, but the word like average in common slang is just like we are actually talking about in mathematical terms the mean. The mode and the median are two other concepts that make up the average in maths. And on its own, the mean can be pretty deceiving. Okay. For example, if I worked for a company and everybody earned like 40 grand, then the mean mode median would be 40 grand. If you put somebody in the mix who earned 400,000, suddenly the mode would be 40,000, the median would be 40,000, but the mean could be like 80,000. And somebody could say the mean salary in this company is 80,000. Now, the vast majority of people don't earn 80,000. So it can be used to just kind of twist the reality And part of why statistics is important is just having an awareness of when somebody is trying to use them to essentially try bamboozle you, especially in the modern age where it can be very, very confusing with the amount of information we have to deal with. So I think that's the end of question 2. So as always, if you want a copy of these notes, send me an email at shanetroy@gmail.com. Like and subscribe to get access to more playlists. See you on question 3.